and we'll take a look. Okay, so we are continuing our discussion of data visualization, and so far we've seen things like geom point, and we talked about creating a plot with geom point, and with geom point you can change the X location and the Y location. You can change the shape of your dot or your point. You can change the size of your point. You can change the color of your point. There's other values. There's alpha, which is like the transparency of the point. There's a lot of stuff that you can kind of do with points. But sometimes there's other plots that perhaps do a better job, or might be different. I guess depending on the data, depending on what kind of graphic you want to make, what kind of visualization you want to make, you might want to use some other kind of geometry, some other kind of geometric object. And so today we will look at geom_col, the column geometry, basically like a bar. And there's also geom_line, which allows you to draw lines. And both of these are handy. There are lots of different geometries. Okay, a student on Campus Wire said, hey, how do we, what do we do for reading? Okay, so right now, be reading chapter 3. Chapter 3 is about kind of our what do you call it, the like the grammar of graphics, and so this is kind of the chapter we're reading. Today's lecture is related to bar graphs, line graphs, and things like that, and this comes from I'm going to be drawing stuff from this textbook, the R Graphics Cookbook, okay, which is a very good reference as well. And so you can go to chapter 3 on bar graphs, chapter 4 on line graphs, and there's quite a bit on geom point and scatter plots as well, okay? So in for chapter 5 on scatter plots, there's all of these different things. Now this is this textbook, the R Graphics Cookbook, I mean, sure, you could read through it like you would a regular book, but I think it's one of those books that are, better as a reference. So, as you're working on something, you go, oh, how do I do that one thing? How do I do that one thing? The R Graphics Cookbook, you can kind of look up like, oh yeah, how do I deal with this issue of overplotting, right? So sometimes you get this where you get all of the dots plotted right on top of each other because you have so many dots, right? 54,000 points in this data set. Well, one thing you can do is you can decrease your alpha, which is the transparency. And so basically each of these dots become like a shadow, a faint wisp of a thing. And when there are a whole bunch of dots stacked on top of each other, you see kind of darker regions, versus like over here, you can't really tell what's going on. So, all of these things, these are just kind of like great little reference things that that are very handy, okay? Oh, some of you guys just arrived, and so my appeal is, if you're willing to turn your camera on, it is much appreciated to have your camera on. But if you don't want to turn your camera on, the alternative that you can do that will let me know you're here is to give me a thumbs up reaction on Zoom, and so I will happily accept that. But of course, yeah, cameras, I appreciate that, turning on your camera. That makes me happy. Okay, so anyway, that's what we're doing, and then on Friday I'm going to start looking at kind of data wrangling, data manipulation, and that's going to start, you can start taking a look at chapter 4, but that's what we're going to do. Now, there are tons of geometric objects that you can do, and so so far I've covered like the geom point object, and today we're going to look at geom column and geom line. But the website, the ggplot website, which is probably one of your best references, okay, there are a ton of different kind of geometric objects that you can do, right? So you have the the whatever, I don't know, the box plot, the contour, the count, the density, the frequency poly, the map, the path. And so you can kind of think like, oh, well, how do I do something? And these are different things that you can kind of consider. Okay. This cheat sheet is also really great. So let me go ahead and open that up. And so this is a very handy reference thing. And so this gives you a sense of like, oh, what are some of the different geometries that I can do? And it's got like a little mini picture of what it is. And so you can kind of see like, oh yeah, you know what, I wanted to do, I don't know, something that looked like this. And you can kind of, you say, oh, okay, that's the object we want to do. And then you can look up the reference to find more details about it. Okay. And then of course, the internet is the greatest reference creation of one of the great creations of mankind, in that we can access almost all kinds of knowledge out there. So those are some things there. Okay, well, let's start off with bar graphs, right? Bar graphs, or the column geometry. And so here, just you can imagine a very small data set, okay? But any kind of data set really, where you have one column in your data represents a categorical variable or categorical value. So here we have three groups, a control group, treatment group 1, and treatment group 2, right? So you can say like, you could imagine something like, what fixes headaches, and you can have control group, just drink water. Okay, treatment group 1, Tylenol and water, and treatment group 2 will be Advil and water, or something like that, right? Acetaminophen, ibuprofen. And you can say, okay, and then let's compare these things. So you have a control, you have treatment 1, treatment 2, and then perhaps you've taken some kind of measure. Here we've measured weight, but it could be like, okay, how long until your headache went away? You time how long it takes for the headache to go away or something. And these are the, kind of a summary of the results, and you want to create a plot of this. What do we do? Okay, so imagine your data looks like this. Well, we can do geom column, geom underscore col column. And we just say, hey, you know what, let's put group on the x-axis. So we will get control, treatment 1, treatment 2 on the x-axis. So different positions there. And then how tall should my bars be, or the columns be? The columns use the height in the weight column, right? So I got 5.03, 4.6, and 5.5 basically. And that's that, okay? So I got ggplot, AES maps the variables to those things. So again, X and Y have to show up in AES. And I say I'm gonna do geom underscore column. And then theme line draw just kind of makes my plots, it just draws the lines for the tick marks and stuff, okay? All right, so far so good. Give me a thumbs up if that looks okay. All right, okay, I appreciate that. Okay, so we'll let's take a look. All right, so there's a few other things that you can do, right? So this is kind of your basic, these are the default settings that you just kind of plots in gray, which is fine, but if you have a color display, maybe it looks prettier and things like that. So here you can there's a couple things you can do. One is the fill color, which is the color that goes inside the bar. And then the color here is actually like the outline color, right? So you have the outline color. So here I said fill color is light blue, outline color is red. And so, yeah, this is what color choice is this? This is like, I want to say like the Montreal Expos or something, right? But anyway, so this is, and these are just right here, I did a setting. Okay, so notice these are not inside AES, so no data is being represented by this. This is just a color choice, a setting. So nothing is being communicated here, but you can, if you had a variable, right? You could put the variable and put it inside AES, right? And if you put it inside AES, now the fill color will be associated with a variable, okay? Or the outline color will be associated with a variable. It might be tough on the eyes if you do something like that, but it's something you can consider. If by default, this is kind of the size, the width of the bars, you can also change the width of the bars. Again, these are settings. So right now I'm doing settings so that, you know, all of the bars end up the same width. But again, you could put any of these, you know, aesthetic attributes inside the AES function, right? You wrap it inside AES, and then it will be associated with a variable, right? So if you have a numeric variable and you want to say, okay, well, for when the numeric variable is big, make the bar wide, and when the numeric variable is small, make the bar skinny, you could do that. I think, I don't know if people are accustomed to that, but it's certainly possible, okay? So you can set the width to be 0.5. You can set the width, the maximum value for the width is 1, where there's like no gap in between them. The default value for width is around 0.9. This is what 0.9 looks like. Perhaps, you know, rather than changing some of these other settings, you know, you might probably a more common scenario for changing the colors in a bar plot or, you know, column plot or whatever we want to call this thing, is if you have like multiple categorical variables that you want to represent. Okay. So here we're going to say, you know, we've got 2 categorical variables. And one we're going to map to the X variable, the X position. And then another variable, the other categorical variable will map to, say, the fill color. Okay. And then, and we have a Y variable, and we have a numeric value there. Okay. So here we're going to say, you know, there are, say, 2 sales teams. There's sales teams A and sales team B. And I don't know, sales team A, you know, has, you know, this manager, and sales team B has a different manager or something. And, you know, they you know, sell stuff on different days of the week. And we record, you know, how much they sold, right? And depending on how you map these things, which one you map to X, which one you map to the color, it will draw a little bit of attention, and you know, it's a little bit subjective, but yeah, let's take a look, right? Which mapping draws more attention to the difference between, say, the days, Wednesday versus Friday versus Saturday, and which one draws more attention to the teams, team A versus team B, right? And so you can kind of take a look at these things. So so we got, you know, team A and team B, you know, their Wednesday, Friday, Saturday sales for these things. Okay, so what do we have here? This we have on Wednesday, team A versus team B. A is in pink and B is in blue. All right, and again, these are just the default colors of ggplot. And again, if you wanted to change the color choices, you could do that. But here, so we see Wednesday, Friday, Saturday, and kind of the side-by-side nature of these things show the contrast, I think, in my opinion, between, you know, team A versus team B, team A versus team B, team A versus team B, and we kind of see that there, maybe. Okay. So here I have the date, Wednesday, Friday versus Saturday, I guess day of the week, on the x-axis, and then the fill color is associated with the team. Okay. Position equals dodge means we put those things, the A color and the B color side by side. They, you know, we put them side by side. What is this? Okay, so over here we have team on the x-axis. So we have team A over on this side of the x-axis and team B on this side of the x-axis. And then the fill color is now associated with the date. So we have Wednesday, Friday, and Saturday. And we can see, okay, this is Wednesday, Friday, Saturday, Wednesday, Friday, Saturday, right? So I don't know, what do you guys think? If I wanted to draw more attention to how days of the week affect sales, should I use this plot or this plot? What do you guys think? Days of the week, do I want to do fill equals date, or do I want to do X equals date for how does days of the week affect sales? It's a little bit subjective, but I would say if we wanted to kind of show the difference between days of the week, I think this one does a little bit better, the second one, because they're put all side by side and we go, okay, Wednesday versus Friday versus Saturday. We could say, oh yeah, you know what, Wednesday, Friday, Saturday, Saturday's the most, Wednesday's the least, for team A and team B. Okay. This one, I think, brings more attention, not to the days of the week, but the difference between team A and team B, right? And so, you want to kind of keep these things in mind. They're both showing the exact same data, right? Both showing the exact same data. If you wanted to kind of, you can draw the same conclusions from either of these things, exact same data in both of these things, but one of these plots might communicate, one of the ideas a little bit better than the other. Okay. Another thing you could do is you could stack them. So over here, we have these side-by-side things. Here we can kind of stack them instead, right? And so this is team A versus team B, or team A and team B, and then Wednesday, Friday, Saturday. So what does this do? So now that they're stacked, it's almost not impossible, but it's much more difficult to compare the performance of team A to the performance of team B because they're stacked on top of each other, right? So if I say, hey, did team A or team B have better sales on Saturday? It's a lot harder to tell, okay? Versus over here, it's very easy. You can say, okay, team B barely edged out team A on Saturday. Over here, it's like you got to really like write down your numbers to figure this out. Okay, it's a lot harder to tell that. Okay, but over here, but you can see, oh yeah, Wednesday, Friday, Saturday, overall this summary is like this, and so this changes a little bit, and this like almost removes the competitive nature between team A and team B, and this is a little bit more like, oh, we're one big happy family and we're all working towards the same goal. And what we see is, Wednesday, Friday, Saturday, there's a difference there, right? So again, same exact information presented just slightly differently. Things are being communicated, things get communicated differently, right? Similar kind of thing. Now we're really just comparing team A and team B, and we have the breakdown between Wednesday, Friday, Saturday, but again, the when it's stacked, it looks like this. Okay, so again, different kinds of things that we have going on. Another option, okay, so here we just kind of took the totals, right? The total in sales, but if I change the position, so the different arguments for position is position dodge, which puts them side by side, position stack, which stacks them, and then you can also have position fill. And what position fill will do is it makes everything, the heights of the bars all 100%. So rather than, so here we have, on Wednesday, the total sales is less than the total sales on Saturday. But what position fill does is it basically takes this thing and it scales everything. It scales everything so that everything's at 100%, right? And sometimes we want this. Sometimes we want the breakdown. Sometimes we want to say, okay, you know what? This is a smaller group, but we're interested in, the ratio between team A and team B or something like that, right? So you can imagine some, I don't know, some scenario where you're doing like a gender breakdown or, breakdown by ethnicity or something like that. And, less interesting is the total counts, okay, where you want different heights, but maybe like the proportion that each group makes up, okay? And so you have position equals fill over here, all right? And the same idea, you could do position fill, and, we have the three different colors, okay? Again, and I feel like I keep repeating myself here, but all of this is all based off of the exact same table of data, right? This same table of data, and it's just being presented in slightly different ways. And each of these things, although they communicate the same data, there is, the impression that it leaves us and what our eyes are drawn to first is is a little bit different. And I think that that's going to be a key idea behind data visualization is you want to ask yourself, what am I trying to communicate? And which of these plots does the best job of communicating that idea? All right, let me go ahead and give you your first view quiz answer. And that is the letter A. A as an apple is your first view quiz answer. And just let me know you're here. Give me a thumbs up. But A as an apple is your first view quiz answer. A as an apple. Okay. All right. Okay, appreciate your reactions here. All right, so let's look at another example. Here is a data frame. This is it's, I guess it's older data frame, but they looked at census data from the 2010 census, and they compared it to the year 2000 census. And we had the 2020 census, and there's lots of even more data and stuff, and some of these trends are still kind of holding up. Okay. Basically, one of the variables measured is change, which is how much did the population for this state change between the year 2000 and the year 2010. Okay. And between the year 2000 and the year 2010, Nevada, the state of, I don't know, Nevada, whatever, grew a lot, right? Like it went from, I mean, Las Vegas now has a football team, which was, they didn't have one for, and they got a football team, a hockey team. It just kind of reflects like the growth of the city and the state and things like that. So so Nevada grew a lot from 2000 to 2010, and it's still growing between 2010 and 2020. You'll see a huge difference. But here, this is just what we have. Other states that had an increase in population: Arizona, Utah, Idaho, Texas, and things like that. They have marked the region, and I guess you have the West, the South. I don't know. When you ask how many regions are there in the U.S., you're always going to get different answers, right? So you have, the West, the South, the Midwest, the Northeast, and then, or like Mid-Atlantic, Pacific, the Rockies, I don't know, right? Mountain area, right? So I'm not quite sure how they've decided to divide these things up. We got the state name and the abbreviation and things like that. And so here we're just looking at the top 10 states, right? We look at change, we arrange them in descending order by change. And then here, slice 1 through 10 just says, hey, give me the top 10. And the 10th row, South Carolina got a little bit cut off, but that's what we have here. Okay. And I got UPC for US population change. All right, so here we're going to just plot that data frame, the 10 things. And here I did, we're going to put the abbreviation on the x-axis. So we get Arizona, Colorado, Florida, Georgia, and so on and so forth. By default, it arranges the x-axis in alphabetical order, okay? And so it goes Arizona, Colorado, Florida, Georgia. It puts them in alphabetical order by the abbreviation. So so that's kind of the default thing. And why we put in the change, and so we can see Nevada has the highest at 35%. And then we filled by region, and in our data set, there were only two regions represented, South and West, and so it picked, pink for South and blue for West for the colors here, and that's what we have. Okay, we can change a few things. If I say, you know what, map fill change, the fill color to change, okay, so no longer the region is no longer populated, is not shown on here. And what we see is that the tallest bar gets the brightest color, and the shortest bar gets kind of the darkest color. All right, so that's what we end up having here. Okay, still x-axis is in alphabetical order. Now, if we wanted to, we could say, you know what, I want the x-axis not in alphabetical order, but I want it in the order, I want it rearranged so that the tallest bar changes on one end and the shortest bar is on the other end, right? So here I'm going to say x-axis reorder the x-axis by reorder the variable abbreviation in order of change. And so we see South Carolina, which is, had the least amount of change in the top 10, okay, 10th versus, and then Nevada is on the right. And because fill color is mapped to the change value, we also see this kind of this gradient in color change from, darkest to brightest over here. And then there's also we also see by having fill color, we also see there's kind of a stark jump between Arizona and Nevada here in terms of color, right? The color difference between these things, I think our eyes say, oh, there's kind of this, okay? UPC is just is an object I made up based on US population change, okay? So there's a data set called US population change, and all of these things come from the data set G cookbook, graphics cookbook, okay? So you load up library graphics cookbook, and then you get US population change as one of your data sets. And here, after I rearranged them and just took the top 10, I called it UPC. All right, so this is what we have. This is if by the default colors are kind of this pink and this blue. If you wanted to change the default color, not the default colors, if you wanted to change the colors, you can use scale fill manual, okay? Scale fill manual, and you put in the colors. And so these are hex codes. I don't know if you're familiar with hex codes, but you can look up, okay, so you can look up, color hex codes. And, there's all kinds of different, the color picker and things like that. And you can say, oh, I want this. And you'll get a little code here, all right? And you can, these different things. I think what I did was I looked up UCLA brand guidelines and what were the colors, and they have, the hex codes for some of these colors, I think. I don't know what I picked here. 3284 BF. I think that's one of our colors. Okay, maybe not. Maybe I'm making something up here, but anyway, you have different colors that you can kind of choose from, and you put in the you can put in your hex codes there for choosing different colors. I think you can also put in like names like red and blue and stuff like that. Okay, so here, so we have that. So for categorical things, you can do scale fill manual here. You can also, if you have a numeric variable, right, you can do scale fill gradient, right? And so the default gradient color goes from like dark blue to light blue. You can change the gradient color to say red to blue or something, right? Low value is red, high value is blue, and you can do that, and you get shades of pink and purple for in between, okay, or magenta. I don't know, whatever you would call this thing. So these are just different options for changing some of these things. Okay. All right, I gotta pick up the pace here. Let's look at, let me give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear. B as in bear is our second view quiz answer. B. So all of these things we've been doing geom column, okay? Geom column, which kind of says we want this, variable, this numeric variable mapped to the Y, okay? And that makes sense. Sometimes you don't actually have a variable that you need mapped to the Y. You just have like a bunch of different categories. And so there is something called geom bar. And what geom bar will do is it will go ahead and kind of tally up and count each of the different categories that you have. So here I've got this very big data set with around almost 54,000 rows, okay? 53,940 rows. And this is like a bunch of different diamonds, and like how big is the diamond, and diamonds if you ever go diamond shopping, there's like different things that you have to look out for, is like, what is the quality of the cut? And you have like good cut and premium cut and ideal cut diamonds, and the color of the diamond, if the diamond is this pure white color, it sells for more money. And if it's like yellowish, it sells for less money. There's clarity, which, natural diamonds often have little impurities in them. And so if there's like no impurities, you get this very clear rating and it's worth a lot. And if there's lots of impurities, you get this, included rating and it's worth less money and stuff like that. Obviously, the size of the diamond, which is the carat, which is like kind of the weight of the diamond, this is all kind of factors in here. So anyway, this is just a data set where they recorded information on like 54,000 different diamonds, 53,940 diamonds. And so let's say we wanted to know how many of each cut there are, okay? So here I can do ggplot AES X equals cut. Notice I don't put anything for Y. I don't have any variable mapped to Y. And instead of geom column, I use geom bar, okay? And what does this do? Well, ggplot says, oh, you know what? You didn't give me anything for Y. I will just go through and I'm going to count how many times each cut appears, right? And it says, okay, I saw fair cut and it appeared this many times. Good cut appeared about 5,000 times. Very good, I don't know, 13,000. Per premium, maybe, or I mean, this is like 12,000 and this is like 14,000 and this is like 20 something thousand. And it just creates the bar graph based on that. So no variable gets mapped to Y. ggplot goes and does the work for you, and it tallies up how many of each variable it saw, how many of each category it saw. What you can do is you can further map additional things. And so here I'm going to say we're going to map fill color. I mean, the color of the diamond. So remember, color of the diamond is the purest, the whitest diamond, I think, is D color. And then I think they go down to Z. So Z would be like this kind of this, like an amber yellow color or something. I don't know. Let's see. I'm just curious. I was watching some baseball highlights. All right. So diamond color guide. Let's take a look. Okay, diamond color chart. Okay, so colorless DEF, and as they you get lower ratings, you get yellowish diamonds, which I guess are less desirable. So anyway, this breaks down the ideal cut diamonds into kind of different segments, right? And so I don't know how useful this is. This just like adds colors and I go, oh, that's pretty, but I can't, for me, if somebody asks me like, hey, are there more colorless premium diamonds or colorless very good diamonds, like I can't answer that. I have no idea, right? Like I'm comparing this bar with this bar. It's not very handy. Okay. So instead of doing so the default is kind of the stack. What I can do is I can do position equals dodge, and it puts them side by side. And we go, okay, so we get a little bit of this, which I don't know, I guess was a little better. I don't know, it communicates something different, although I'm still not quite sure what I should be getting out of this plot, right? What should I be observing? More ideal cut diamonds? But so now the total number of diamonds is a little unknown, right? Now it's harder to compare. Are there more premium diamonds or very good diamonds? And it's a little bit harder to see. You can kind of go, oh, I guess there's a few more premium. And this is much easier. You can see, okay, there's more premium diamonds than very good diamonds. Here, you kind of lose that. It's harder to compare the total number of premium versus very good. But now you can kind of compare some of these individual things and you go, oh, there's just a few more premium colorless, premium D color versus very good D color. But yeah, I don't know. Okay. Perhaps this could be useful. If you do position equals fill, now you can see kind of proportionally the number of D-rated diamonds has a proportionally they're all kind of around the same except for the fair cut diamonds. Very few D-rated, and then you end up having a lot more J-rated diamonds for fair cut versus some of these other ones. So each of these things communicates something a little bit differently, but it's one of the problems is we got way too many kind of colors and categories. So having a bunch of colors and categories kind of looks pretty, but also it's harder to interpret. So, probably it would be better if we, combine some of these things. And we said, if, by looking up a little bit about what happened, we could say, oh, if I combined DEF, right? If I combine these three things, right? That would be probably easier for us to compare DEF and what was the other one? G and H and IJ. If we combine them into just three groups, into like colorless, near colorless, and what was the other? I don't know, whatever, right? So again, you need to have something, some kind of expert, right? The subject matter expert that can kind of tell you some of these things, how best to analyze your data. Because just having 7 categories is, it's okay, but it also makes interpretation a little bit harder, right? There's more things for us to keep track of. Here is same data, just presented ever so slightly differently. Here I mapped the color to the x-axis and the cut to the color, right, of the bar, and this looks different. Same information as this, just presented differently, all right. And one thing that this illustrates though is we say, oh, you know what? There's quite a few more G colored diamonds than there are, say, J or D colored diamonds, right? So now we get a little bit more of this almost this normal, not normal, but like this distribution where G is kind of more common than some of the more colorful diamonds and colorless diamonds or something. Okay, that's kind of just your quick summary through column and bar plots. And so the last few minutes we'll look at line graphs, okay? So line graphs, you can use geom_line, and you'll have a variable x mapped to x and a y mapped to y. And they're kind of like a scatter plot, except they're joined with a line, okay? So basically this will give you an x coordinate, this will give you a y coordinate, and it joins them with a line. So, we have x, 1 at 8.3 and 2 at 10.3 and 3 at 19.0 and 4 at 16.0. So 3 at 19.0, 19 point something, and 16.0, I think. And so it's kind of like x and y. So it's like a scatter plot or a dot plot or a geom point, okay? Like geom point, scatter plot type of thing, except it's joining them with a line. And that's what this is, right? So you do time to x, demand to y, and we're going to join them using geom_line. There is another function called geom_path, right? And for this, geom_line and geom_path produce the exact same thing. If your data is arranged so that the x variable mapped to x is in increasing order, geom_line and geom_path will produce the exact same plot if your x variable is in increasing order. Okay, but you might be in a situation where the variable that you have mapped to x is not in increasing order. Okay, so here I said take my data set and I'm going to arrange them based on demand here. Okay, so demand is now in increasing order, and so the variable mapped to x, which is time, goes 1, 2, 5, 4, 3, 7. 1, 2, 5, 4, 3, 7. So this is no longer in increasing order. All right, and geom_path connects the line in the order that they appear in the table. So it's going to go from 1, 8.3, to 2, 10.3, to 5, 15.6, then to 4, 16.0, then to 3, 19.0, and then to 7, 19.8. Okay. Whereas, oh shoot, this is a typo. I apologize. You need to fix this. I gotta fix this. Okay. Whereas geom line, okay, geom line connects the line based on increasing x variable. So geom line will never go backwards. You'll and I'll illustrate that. So okay, so sorry, you need to fix this on slide 32, geom line. And let me give you your third and final view quiz answer for today, which is the letter C. C as in cat. C as in cat. Okay. So geom line, not geom path, geom line connects the line based on increasing x variable. Okay. And third view quiz answer is C. C as in cat. So here is geom line. It connects in x increasing order. So it goes from x1 to x2 to x3 to x4 to x5 to x6 to x7. Or actually, there's no x6. Okay. But, you know, basically from 1 to 3, 2, 3, 4, 5, 7. Okay. And this puts them in the order that it sees in the table. In the table, it goes 1, 2, 5, 4, 3, 7. So it goes 1, 2, 5, 4, 3, 7. Okay. So path goes in the order in the table, order of the table, and this is order of x variable. Okay. So here I've got time. So even though time is not in order, okay, it connects the line in the order of the x variable, increasing x. Okay. And here, geom path, it looks at the order of the table, 1, 2, 5, 4, 3, 7 for x, and it connects it in that 1, 2, 5, 4, 3, 7. Okay. Are we okay with that? The difference between geom line and geom path? Because they're similar, but they are different. Similar but different. So if we understand that, give me a thumbs up. All right, I appreciate the thumbs ups there. Okay, so that's geom line, geom path, and so we have that. Okay. Sometimes we want to draw multiple lines. Okay, sometimes we want to draw multiple lines. And so here, this is from some, I don't know, some silly experiment. I don't know who ran this experiment, but they looked at guinea pigs and they gave some guinea pigs orange juice and they gave some guinea pigs vitamin C, and then they measured how much their teeth grow. I don't know who came up with this experiment, but apparently somebody said, all right, we're going to do this. We're going to give you some orange juice. We're going to give some of you vitamin C, and we're going to measure how much your teeth grow. And this is the data they recorded. And so we have one of the groups is orange juice versus vitamin C. And then we looked at how much, right, the dosage, 0.5, 1 versus 2. And then we measured how much their teeth grew, I guess. Okay. All right. And so what do we see? Here I've got X mapped to the dosage. So from 0.5 to 1 to 2.0. Y is going to be how much our variable, the length variable, how much the teeth grew. And then the color of the line will be which group it was, orange juice versus vitamin C. And so we can see, okay, this is what happened with orange juice. This is what happened with vitamin C. And so, dosage 2, we had similar performance, but at lower dosages, orange juice seems to result in more tooth growth than vitamin C. I don't know. Okay. This is an interesting experiment. So that's what you have, right? So you can look at the color of the line. Now these lines are kind of thin, a little bit hard to see. So you can say, all right, you know what? Let's increase the width of the line, and so you can do line width equal to 2, and that makes the lines a lot thicker. All right, and this is honestly, if you wanted to, you can change line width and map it to a variable, right? If you have another variable. So any of these things that you can change, you can also put it inside of mapping. And so if you wanted to change the width of the line based on some variable and have like a really fat line versus a really thin line, I mean, I don't know if I would agree with that decision, but it is possible. And you can do that. Actually, there is a great visualization that includes the width of the line. And this is a famous visualization. Let's see, Napoleon's March visualization. So this is considered one of the greatest visualizations of all time, data visualizations. And this was, when was this made? Okay. Can I look at this, please? I want to show this very important thing. Let's see. It's on Wikipedia somewhere. Let's look up Wikipedia. The underappreciated man behind the best. Okay, so here is considered to be one of the greatest visualizations of all time. So this was, Napoleon, tried to, invade Russia in the winter, right? And that, we all know that's like a bad idea. And here, the thickness of this line represents how many troops he had, okay? How many troops there were. And so we can see the line starts off very thick, okay? And as they march towards Moscow, okay, the line gets thinner and thinner and thinner. And then, they have to turn around. And as they're turning around and walking back, that line gets thinner and thinner and thinner and thinner and thinner, right? And so here, the line width actually represents an important variable, which was basically the troop strength, right? How many troops there were taking part. So that could be something, if you wanted to plot in your data set, you could use the line width to represent some kind of variable that exists in your data. So that is possible. Although, you have to, again, all of these things, you have to think about what is it that you're trying to represent. Okay, so this data visualization, the line width shows the troop strength, and the position kind of shows the path that they took, and then there's a few other things. This is the temperature at some of these locations on the way back. These were the temperatures that they faced, and you can see that it got colder and colder and colder as what do you call it? Time went on, right? As it got further into the winter, it got colder and much harder. So that's line width. You can, here is just a setting, doesn't communicate anything in the data, but you could map it to something so it communicates something in the data. Okay. Sometimes you're dealing with you have to print it out in black and white. And so instead of having color, because both of these lines would just print in gray, you can change, all right, you know what? I want a solid line versus a dotted line. And here that's the variable line type. Okay, line type. And again, all of these things you can read more by looking up the reference, that textbook I referenced in the beginning, our graphics cookbook. You look that up and you can see a lot of kind of the different options here. Okay. All right. I think I gave you all 3 view quiz answers. And we will go ahead and end here for today. And we will see you all on Friday. All right. Have a great rest of your day.